Okay, good day guys. So we're here to discuss the terrestrial triangle. So what is a terrestrial triangle? So a terrestrial triangle is a triangle wherein if we have 2 points anywhere on the terrestrial sphere, we will just be considering any 2 points, and the third point will be either the north or the south pole of your terrestrial sphere. So for example, for convenience, what we usually use is the nearest pole. So in this case, if you would notice, say for example, point A and B are both on the upper hemisphere. Say for example, here is your equator, so they are both on the upper hemisphere. So we will be considering the north pole as the third point. So say here is your north pole. Okay, so there is your north pole. So to create your terrestrial triangle, all you have to do is to draw the circle of longitude passing through both points. Say point A, say this here is your circle of longitude of point A, and another circle of longitude passing through point B, and we just have to create a great circle passing through 2 points or through these 2 points. So remember, if we have 2 points on the sphere, we can always create a great circle passing through those 2 points. So let's create a great circle passing through those 2 points. For example, that one. So this now will be your terrestrial triangle. So next is, what will be the parts of this terrestrial triangle? So since point A is here, and if we try to write or draw your circle of longitude passing through point A, okay, and then we try to intersect the equator, remember that this distance from the equator to point A along this circle of longitude will serve as the latitude of A. And then same thing with here. If I try to continue drawing here, this will serve as your latitude of B. So for convenience, so since this is the latitude of A, and since from the equator going to the North Pole, this is 90 degrees, it's some sort of, we denote this to be the complement of the latitude, or simply the colat of A. And then same thing here, we will be calling this colat B. Next, so since we are to consider, we made a great circle passing through point A and point B, we will denote this to be the great circle distance between A and B, and then we denote this to be your small n. Okay, so the next thing is we will try now to identify the angles of your terrestrial triangle. So since, notice that your this one is the circle of longitude passing through point A, this is also the circle of longitude passing through point B. They have some sort or rather point A has a longitude, same thing with your point B. Say for example, here is your prime meridian. So notice, here is your longitude of A, and here is your longitude of B. So what can you say about your angle N? So it will serve as, notice that it will serve as the difference of the longitude, or simply the d-long between A and B. Next, how about this angle A and angle B? So with this, we can actually use these angles. In this case, since A is on the left of B, we can actually use these angles A and angle B to find for the bearing or the course from A to B and vice versa. So we're finished with the terrestrial triangle. So again, let's try to enumerate the parts. So first is, we have colat of A, we have colat of B, and then the third side will be the great circle distance between points A and B. And then your angle N will serve as the difference of the longitude, or the d-long between A and B. And then your angle A will be used to identify the course or the bearing from point A to point B. And then your angle B will also serve, or will be used to find for the bearing from point B to point A. So we'll be using this for our next activity. Okay, next, what if points A and B are on different hemispheres? Notice I've drawn point A on the upper hemisphere, and then point B is on the lower hemisphere. So the name colatitude a while ago is somewhat kind of confusing because we just have to call it colat, but or the complement of the latitude. But so that we can just easily name that the two sides. Say this one is still colat of A, okay, and this is colat of B, okay. But remember, whenever we try to find the colat of points A and B, we have to consider the pole that we are to use. In this case, your colat of A here will really be the complement of the latitude. But in this case, instead of calling it the complement, your colat of B will now be the sum of the 90 degrees and the latitude of B. So I hope we are not confused with that. So a while ago, if you would notice here, both colat of A and colat of B will be really literally the complements of the latitudes of A and B. In this case, we will have a different variation wherein your colat of B will now be, in this case, if to find for colat of B and then say colat of A. So to find for colat of A, in this case, all we have to do is to subtract the latitude of A from 90 degrees. But in this case, colat of B, in this case, will be 90 degrees plus the latitude of B. Okay? And in this case, since they are both on the same hemisphere, your colat of A and colat of B, colat of B, okay, they both have the same way on how to find. We just have to subtract from 90 degrees both the latitudes of A and the latitude of B to find both colat. Okay, so I hope it's clear on how to find for the sides of especially the colats of points A and point B. Okay, now next, how about the D-long? So the D-long, again, we have to consider where is the positions of your point A and point B with respect to either they are both on the right hemisphere or on the left hemisphere, or to from the primary region, so it goes to the right or eastward, or goes to the left, which is westward. So if I try to consider getting the D-long of this, so it's literally, in this case, the difference of the longitude of A and B. Or in other words, to find for your D-long, in this case, angle N, you just have to get, since your longitude of B will be bigger compared to the longitude of A, so all you have to do is to subtract the longitude of B minus longitude of A. So you will have the difference of the longitude. What if we have this possibility wherein your points A and B are on a different direction? So notice point A, in this case, if this is your primary region, point A is westward and point B is eastward. So how are you going to find now your angle N? A while ago, we call it the D-long, but in this case, it's not some sort of anymore the difference, but we have to consider the longitude of A and the longitude of B. So to find angle N, it's just simply, in this case, the sum of the longitude of A and the longitude of B. Okay? So I hope we will not be confused on the names, because even if this one, we call it the D-long in this case, but in this case, it's actually now the sum of the longitudes. Okay guys, the third possibility in getting the difference or the D-long of, or your angle N in this case, is this. Now, a while ago, if you notice, if points A and B are on a different hemisphere or different direction, all we have to do is to add the longitude of A and the longitude of B. Now, what happens if the sum turns out to be more than 180 degrees or greater than 180 degrees? So, is it still okay if your angle will be more than 180 degrees? Technically, yes. But before, we mentioned that whenever we try to get angles or any sides of your spherical angles, we have to make sure that the angle should be less than 180 degrees for convenience purposes. So for convenience also, in this case, instead of just adding the longitude, we subtract the sum of the longitudes from 360 degrees. In this case, we have this. Okay, so we subtract the sum of the longitudes from 360 degrees. Okay, so let's just summarize the result. So first is to get the d-long, either if points A and B are on the same direction, simply all we have to do is to get the difference of the two longitudes, of course, the bigger minus the smaller longitudes. The next possibility is if A and B are on different direction, all we have to do is to add. But make sure if the sum turns out to be less than 180 degrees, then that's the d-long or your angle n. Otherwise, if your d-long, or rather the sum of the longitude of A, and the longitude of B turns out to be greater than 180 degrees, okay, or more than 180 degrees, all we have to do is to subtract the sum from 360. Okay, again, this one is the case wherein your points A and B are also in different direction. Okay, usually point A will serve as the initial position, and then your point B will be the final position of this great circle track. So a while ago we mentioned that your angle A and B will be used to find the bearing from point A and B, or point A to B, and vice versa. But sometimes, or most of the cases, your angle A will serve as, or will be used to find for the initial true course, and then your angle B will also be used to find for the final true course. There are a few possibilities in getting the initial and the final true course of our problems. There are a few. There are actually 4 possibilities. The first possibility is when we have this, okay, so when your point A and point B, or rather your initial position will be to the left, and then your final position is to the right, and the pole that we are to consider is your north pole. So to find for the initial true course, in this case we call it the ITC, okay, notice your initial true course will just simply be your angle A. So since we have to get the true course, that will just be whatever is angle A, that's already the initial true course. Now, how about the final true course, or the FTC? So the final true course, to find for the final true course, sorry about this, I'll just write it properly. Okay, so to find for the final true course, remember that the final true course will be the course going to the direction of your ship. So in this case, here is your final true course. But where is angle B? Angle B is here. Now, so since your angle B, or rather this one, is a great circle track, this whole angle here will be 180 degrees. But the final true course here will be this angle here. So what can you say about the final true course? So using angle B, notice angle B will just be the supplement of the final true course. So to find the final true course here, all you have to do is to subtract, okay, 180 degrees and your angle B. Okay. The next possibility is when you have an opposite direction, or your point A will be to the right of your point B. So what happens to your initial true course and then your final true course here? So to find for the initial true course, again, this will be your so by the way, the true course will be the angle from the north clockwise. Okay, so in this case, instead of this one is your angle A, right? So to find for the initial true course, it will be this angle here. Okay, so again, the true course are from the true north clockwise. Okay, so using angle A now to find for the initial true course, all we have now to do, again, notice this one is one whole revolution, or that would be 360 degrees, and then using angle A, so the initial true course in this case will just be what? So one whole revolution minus your angle A, which is 360 degrees, minus your angle A. Now, how about your final true course? same thing, final true course from the true north. In this case, this is your final position. From the final position going to the direction we are going, right? So that's your final true course. But where is your angle B? Angle B is this angle. So what can you say about your final true course? So notice this one again is what? Okay, this one is a straight line. Okay, so this will be 180 degrees. So to find for the final true course, all you have to do is to add angle B and 180 degrees. So this will just be 180 degrees plus your angle B. Okay, the third possibility, or the third and the fourth possibilities, are when we are to use the south pole instead of the north pole in getting the initial and the final true courses, just like this one. So the same thing. So the first one is when your point A is to the right of your angle B, how are you going to find for the initial true course and your final true course here? So to find for the initial true course, so again, from the true north, again, we still have to use the true north. Okay, here is your initial true course. Okay, so but in this case, since we have used a while ago the south pole as your pole of reference for your terrestrial triangle, so this is your angle A here. Okay, so what can you say now about your initial true course? So since this is angle A and then this one is a straight line, or don't be confused with straight lines and great circle tracks. So this is a great circle track, so this will serve as straight line. So this angle here will be 180 degrees. So your initial true course now will be the supplement of your angle A. So in this case, this will just be 180 degrees minus angle A. And how about the final true course? So the final true course, again, same thing. We have to use still your true north. So this will now be your final true course. So to find for the final true course in this possibility, notice that this one is your angle B, right? So we have in our geometry that if we have two intersecting lines, notice that this one is a line and this one is also another line, or a great circle track, another great circle track. Notice the opposite angles are the same, right? Or are congruent. So same thing, since this one is congruent, so your final true course here will just be angle B. Okay, let us proceed with the last possibility. So the last possibility is when, again, we reverse the position of your point A and B, or the initial and the final position. So the initial course, or the initial true course here, will be what? Okay, so the initial true course, again, so from the true north, always remember, so whenever we try to find the true course, it's always from the true north. So it will be this angle here. Okay, so your angle A will be this. So what will be your initial true course? So again, this one is a straight line, or a great circle track, so this will be 180 degrees. And this, which is angle A, will serve as the initial true course. So this will just be 180 degrees plus your angle A. And finally, the final true course. So the final true course, again, from the true north going to the direction we are going. So that's the final true course. So how are we going to get that? Remember, this is your angle B, right? And notice angle B here will be same thing. This one is a line and this is a great circle track. So this angle here will be equal to this because they will be opposite angles. So we have to get these angles, and this is also angle B. So we just have to subtract the measure of angle B from one whole revolution. So this will just be 360 degrees minus your angle B. So we're finished with getting all the four possibilities in getting the initial and the final true courses depending on the positions of your points, or the initial position and the final position and the pole that we are to consider. So I hope we're clear with all the parts of this terrestrial triangle. So the only thing that we have to get simply is the great circle track because it doesn't change. Okay, so I hope you've learned how to identify these parts, and later on we'll have an example on how to use this in some specific examples, and to further have knowledge on getting the terrestrial or solving for terrestrial triangles later on. Okay, see you later guys, and I hope you stay safe all the times, and be good, and I hope you learned something. See you then.